Hello guys, welcome back to my YouTube channel. My name is Mike Matthew KE and this is my Logic in Programming series. So today we're going to be looking at Tic Tac Toe. How can we implement Tic Tac Toe in code? I already did a video where we looked at the logic, alright, of how we can break down the game logic, how we can approach every step, and now today we'll just be doing the implementation, which will make it a little bit easier. So we're going to be using Python in this case, and an extra library called Arcade, which will at least help us in doing the rendering of our 2D objects, right? So let's dive right in and see how we can do this. In this video also, I forgot to mention, I'm going to be doing it a little bit raw. I hope you like it. It will be more me in the element. Some of the things I'll need to be Googling, so you'll also see that section where I'll need to go back to the manual so that I can see what I need to do in order to implement, right? So I hope you like me doing it this way so that you can also see the process behind, not just a clear-cut video of the process like everything is in my mind directly, right? So let's dive right into the code. So here on my screen you can see Arcade. So this is the Python library I was talking about. It's basically able to help us create 2D games. If for this video specifically, I'll use it to render out. So if you're drawing an X on a screen on the window, so it will help us to have a window and also be able to draw the elements so that it's those boxes where we'll be putting the X and O's and all that. But the game logic now is up to us. So this library just helps us make it a little bit easier, right? So first things first, we need to start our project, right? So here in my directory, I'll create a folder and I'll call it Tic Tac Toe. All right, then I'll come in. So I'll just open Visual Studio Code in this directory. This is where we'll be working. Now in this case, I'll be utilizing, so I'll just reduce this a little bit. Hopefully you can see it well. So in this case, I'll be using a Python environment where basically any extra libraries that we'll be getting from outside that are already implemented, like the Arcade library, I'll be using it within a Python environment, right? So to do that, I'll just open our terminal, new terminal here, and then I'll just create an environment. So how you do that is Python-m, which represents module, venv, which is a virtual environment library, and then venv to just say that whatever libraries it will be using, it will add onto this folder venv. So you can see we already have a venv here. So what this does, when you create a virtual environment, it basically means you do not need Python to be installed in the machine in order to be able to run your code, because everything is within that virtual environment, right? So it's basically created this environment where as long as you have this folder, you can be able to run your Python code as long as it has every element that is required there. The other thing that I'll do here, I'll create a requirements.txt file. So this is where I'll name all the modules that we'll be using. So coming back to our browser, so we're just going to see how getting started, how we should be able to install this. So you can see it's just pip install Arcade. So in this case, I'll just come here and add Arcade as one of the modules that you'll be using in this project, right? So what this does is, instead of me having to go pip install Arcade, right? All I'll have to do is do pip install -r requirements.txt, and what this does is it allows us to list all the requirements that we need for our project here. So whatever requirements that we have, whatever extra libraries we need, we list them here, and once we run this command once, it installs all of them. So one other thing, I need to relaunch this terminal here so that we are able to access the virtual environment, because if I install it here directly without accessing the virtual environment, it will install it in the global scope, right, in the entire computer. So I'll just relaunch terminal. You can just hover over this yellow display for the PowerShell, relaunch the terminal so that it's able to load the virtual environment, and then now I can run pip install -r requirements.txt, and so you will see that we'll be able to install our arcade library, right? So as that is installing, I could be checking how we can start off. So obviously here there are tutorials, there are examples. So what I notice here, there's a starting template right here. So I think we'll just copy this code, right? No need to write everything from scratch when we have a template provided for us, as long as we understand whatever is going on, right? So coming back here, it's still installing. However, as it okay, just finished installing. So now we can create our main file, right? So I'll just call it main.py, right? And then I'll just paste that code that we've gotten from online. So you can see here, this is our starting template. Once you've learned how to use classes, you can begin using the program with this template. If Python and Arcade are installed, this example can be run for the command line using this. Okay, that's good to note. So you can see here it imports Arcade. We have our window width and window height, and then we have our window title. So we just come to update that in a few. You can see now we have a class called GameView, which inherits from arcade.view. So this is how a class inherits from another, right? And then we can see that our init initializes the class which you have inherited from, and then we also have our background color. We have reset, which resets to initial state. That's good that we have that there. Then we have on draw. So this command should happen before we start drawing. It will clear the screen to the background color and erase what we drew last frame. Nice. So we call draw on all your sprite lists below, right? So whatever sprites that we have. Sprite is basically just, you can think of a sprite as just a 2D element. That's basically what a sprite is. So a sprite list would basically be like a list of the sprites. That is kind of self-explanatory. We have on update. So all the logic to move and the game logic goes here. Normally we'll call update on the sprite lists that need it, right? And then on keypress, we also have these functions that at least allow us to do a bit of... So sorry about that. My alarm decided to go off mid-recording. Here we have on key press, on key release. These are basically functions that help us do certain functions. In this case, they are helper functions whenever a certain event takes place. For key press, it definitely be keyboard pressed. On key release is when you press a keyboard, and then when you release that key is when this also runs. We have on mouse motion, that's basically whenever the mouse moves. Mouse press, mouse release, when you press a button and you release a button. I think that's a bit self-explanatory. So this just helps us to tap into those events whenever they occur, right? And then now here we have our main function, which basically creates a window, an arcade window, and then we call now our game view, which is our class that we have created here, or rather that has been created for us. And then we have window.showView. I guess that basically means we are able to render, and then we have now arcade.run, which now runs our game loop. So the good thing about having this library is it assists us, because now we have the template for our game logic. Sorry, not our game logic, but rather our game loop. set up already, right? So it makes it a bit simpler. Now we don't have to worry about how we're going to get mouse input, how we're going to render our grid as well as our X and O's and all that. We don't have to worry about that because Arcade takes care of that for us. All we need to worry about now is how can we use our game logic to fit into this library, right? So if I run this so that you can also see an example of how it will look like. So that's what it looks like, right? We have our window here. We have it named as starting template. We can see it's a 1280 by 720 window, right? So now let's try and start changing up some things, right? So first of all, since we're doing a Tic Tac Toe, the window width and window height, I think I'll settle for 900 by 900, right? And then I'll also give this title as Tic Tac Toe. I don't know about the colors. I don't know what colors exist, but maybe maybe you can do a navy blue, something like that. Yeah, navy blue, not bad. So if I run this, you can see now we've changed it up, and now it's a different window. I think that blue is a bit too bright. Maybe you can do something grayish. Dot gray. So clearly here you can see we are having suggestions. Let me see how gray looks like. Yeah, I think we'll settle for gray. Some of these things we'll change it up later so that we can see how it looks a lot better. But here, let's see. So now, next, what we need is definitely a grid, right? Our grid. So if I try and open the sample that we did last time, this. I'll just open it with Paint so that in case we need to modify a little bit. So you can see here, this is what we have, right? This is the grid that we had shown before. So this is exactly what we need to render. The grid that we did here, we need to render it right now. So now going back to our arcade, how can we render this grid? So we can look at the examples that we have. You can see here we have drawing primitives. Primitives are basically like lines or dots, such things. Let's see. Okay, so here we have something called shape elements list. Let me just see, because I'm seeing a grid here. So you have a screen with 9,600 rectangles. Those rectangles are these points, these colors, these angles. They need to be sent to the graphics card 60 times per second. What you need to do instead is package all these rectangles up and set them into the graphics card and then have them drawn in just one command. All right, nice. This looks like an optimization, a way of optimizing the way we can render. So shape element list. So first, no shape list, just draw a rectangle. Second, each rectangle is individually buffered to the GPU. Third, all rectangles are buffered. So you can see here an example of how they're using it. So I can see it's, sorry, I'm just reading fast. So this demo shows a speed of drawing all full grid of squares using no buffering, right? So you can see here on our onDraw, we have something rendered out. So they're saying, so after our self.clear, which I think we had seen that before, we have onDraw, we have self.clear, and then now we have call draw on all your sprite lists below, right? So here, draw all the rectangles we have for X in range of window width and square spacing. I believe square spacing is how many pixels it will take, right? Excuse me. So we have for Y in range as well. So now we fill our rectangle. I think this is a function. So I'll just pick this up as is, right? And put it here. So I'll just replace this with draw all the squares. or let me call it grids, so that it's a bit more relevant. And then we have square spacing. So now, remember we've done our window width and window height as 900. So if you are doing a split between the three, then we'll have 300 by 300 squares taking the space, right? So that there are three of them, and three of them across and three of them vertically. So for this square spacing, right, which is basically meaning what is the size of our square, then I'll use 300, and then we can see um, square width and square height. Now I'm not sure what the square spacing should be. For x in range of window width and square spacing. Oh, okay, right. So we every time you're skipping, so it's a range. So if you're starting at 0, the next loop will go from now the square spacing length, right? And then next here we'll have our square width and square height, which I'll also default to 300. Or alternatively, since we are expecting this to be the same, we can also equate this to our square spacing, right? So that it changes, in case we need to change it in the future, it will still be the same. So next, let's see. So we have that rendered, and then if I come back here, print the timing. Right, so I'm not sure what this is supposed to do. But however, I think this should be able to render, right? If I try and run this, let's see what this brings us. Whoa, not exactly what I expected. Clearly we're missing something. So let me see, square width, square height, and then square spacing. So let me try to use whatever we have here and see what kind of result we get. Because now I'm thinking there's something we've missed out. So we have 5, 10, and 10. So I just need to see how that looks like fast, because what I thought it was is not what it is. Okay, we just have a blue screen. I'm not sure what this is supposed to look like. Okay, let's make this white and then run that. Looks like just one grid, which is not exactly what we want. So this is clearly the meat of it when you're trying to figure out what this is supposed to do. So let me just copy this as is, right? So you have time it. I'll just exclude time it because this is just showing us how long it will take. And then I'll return this to dark blue as it was. If I run this, oh, it actually crashes. Sorry, yeah, there's this output here that I don't need. Okay, the draw text. So maybe I'll just print X or something like that, so you can see. Okay, so we have X being printed here. So the very least we know how to render our text, right? So I need to know what this draw rect field does. So that's when we go into the manual. So I'll just open this manual here. So there's drawing and using sprites. So what is a sprite? So like I explained before, a sprite is basically a primitive, right? Like for example, a circle or a square, that will be a sprite. So I'm just trying to figure out how we can look at this. So I just need to see examples of how they're drawing. Right, so okay, if I go back to these examples, because we have drawing primitives right here, so let me see how they drew this rectangle. Right, so we can see draw text, draw rec outline. Okay, right, so this is actually what I'm looking for, because now remember we need an outline rather than a filled square, right? Because if we're looking at this, it's the outlines that we need really, and then now we can influence the how the background comes out based on the clear color, right? So if I look at that, I can change this to draw rect outline, right? And then here we have our x, our y, right? And then our square width and square height. That's what I'm expecting. So I'm not sure what. So if I look at this, the definition here, so the border width of the lines. Okay, so in this case, this will be the width of the lines and not the width of the lines in pixels and not the width of the rectangle itself. So here, I'll have to change this so that we can define this as let's say border width and oops. So I'm replacing this square width with border width here, and then this can also right click here and rename, or rather refactor, rename symbol, and change this to border height. Right. Is it really? Actually, you might not need both of them, because if I look at this, okay, let's see first of all how that looks like, so that we can determine what we're doing here. Ah, nice, very nice. So you can see now we have our grid, right? It's a couple of lines. It's a bit small in this case for my taste. However, we can do now our square spacing. We can return our square spacing to 300, and then we can change the border width. We can just use border width, one border width, all right, since it's just a width. And now I expect this to work the way we expected it to work. Oh, something weird is happening here. Did I miss how this is supposed to work? Okay, let me try and change this to 300 and see if that comes out the way I'm thinking it should. Aha, right. Now this is a bit skewed. It's coming out right, but it's a bit skewed. So let me see. I thought I got the handle on how that primitive is supposed to grow. So let me try and go to the manual so that I can see how we can also look at this. Using sprites. I actually like the manual. Let me see. So here from the documentation, you can see width of the lines in pixels, and then rotation of the rectangle defaults to 0. Okay, this is my bad. I'm adding this tilt angle. First of all, seems like we don't actually need that. All right. Am I getting this wrong? So this is our rectangle. Okay, so the first element is our rectangle, right? Which has the x and y, which I believe x and y here refer to. So x and y, then the width and height, right? So this will default back to square width and square height. And then the square height again, like we had before, which is actually the way it's supposed to be, equals 300, right? And then the next thing is, from now our outline expects us to give a rectangle, a color, and a border width, which by default is 1. Right? So we have a color and then we have a width. So I'll just put 1 like it is here. So this is our rectangle, that's the first thing, and then this is our color, and then now we have our width. So if I see how that looks like, so it renders correctly, but we have this, I don't know why we have this space here. It seems like it's skewed. Let me just remove this and see if it's affecting the text. No, it's not. Huh, so what are we doing wrong here? We have our, so we're going from 0 to our window width, and whenever we're jumping based on the square spacing. Is it our square spacing that is messing us up? If I reduce this to 1, let me see what that will do. It's taking a bit of a long time to render. Let me just cancel that. Seems like I've overloaded it. So let me try and play with this. Let's say, for example, 200 and see what that does. Okay. So what I'm not getting here is it's starting from a range of 0. So I'm not understanding why it's jumping across. Because based on this, the 300, it seems like it's slightly skewed in a way that it shouldn't happen. Have a rectangle, we have a, so why is this not working the right way? Or should I just draw, okay, let me attempt to draw one rectangle on its own with something specified, right? And then see how that looks like. So I want 0, 0. Let me see how 0, 0 look like, so that I can determine. Oh, okay. So 0, 0 seems to be the bottom here, and it's not exactly where I need it to be. That's so weird. Where is it drawing? If I try and draw, let's say, oh, wait a second. I think I get what the issue is here. So it seems that our 0, 0, our x and y is the middle of the rectangle, or in this case our square is the middle of the square rather than the edge of the square, right? So this here should be, if for example you do 150 here, which is the middle of our square width, right? Then it should be able to draw the square fully where we need it to be, which means here I will need to take, when we're doing this, the square x and y, so plus square width over 2, and then y plus square height over 2, right? So if I run this now, then we should be able to get our grade. Haha, eureka. So now finally we have something. I think I'll change these lines to white, so that it looks a bit more obvious, right? So now we have our grade. Yay! That was step 1. So now let's continue to step 2. So now that we have our grid, now we can start looking at our game logic. So like you said before, we'll be able to design this. We can represent our grid now in code using using a 3 by 3 multi-dimensional array, right? So this is a 2D array that is 3 by 3. So if I switch it up here, so what we can do here is, once we init, we can create now our main grid. So we can call this self dot let's call it board, right? And then we can initialize it as a list of lists. So in this case, right, so I'll just try to split this up so that we can also view it in a way that is favorable for us, right? A bit of an arrangement goes a long way. So I'll just initialize this to none. So we have this none right there. So that represents what we have drawn, right? So now we have our grid, which has none at the moment. Of course, later we'll change this into the strings, whether it's an X or an O, depending on whether you need to render. So I'm putting none so that you're able to know no item has been put in this place at the moment, right? Now that we have our board represented, now we can come here and also look at how we can render. So so for the sake of practice, let me just put an X here, for example, and an O here. So I can also look at how we can render. That's our biggest task at the moment. So if we wanted to render text, right? So first thing we'd do here, we already have a method that helps us to draw text, right? So here what we'll do is we need to look through each element of the board. So for X in range of, now the length of our, or let me just use 3, in range 3, and then for Y in range 3 again, right? So in this case, we need to evaluate first of all if now our value at xy, so self.board, right? Self.board at x and y. So basically, if it is a valid value, then we can draw text, right? So now this explains why I prefer to use none here, so that if it's none, it will not try to draw anything, but if it's not, then we'll draw text. So we'll draw the text that is there already. So we'll get self.board at x and at y. That will be our text. So I just need to see here. So we have the text, and then we have x and y. I believe that should be the starting position of our grid, if I'm not wrong. So I'll choose x and y as now. So our x would be, we'll just take x plus our window, our square width, or rather x times our square width, right? So that means if I try and go back here, that means so if we have 0 0 here, right? So this will be our 0, this will be a 1, and this will be a 2. So if we are doing x times, in terms of pixels, x times, let's say 300 is now our square width, then this will still be 0. Then times 300 here, so this is our 300 pixel, and then we have times 300 here. This will be our 600, our pixel at 600, right? So that will place our grid in the right way, and I'll do the same for our width here, y times 300. This is small y. In terms of color, let's make it I don't know, something yellow. So now it doesn't matter that much. You just need something that is different from the grid. I believe this here is the font size, which is 12. So we'll see how it looks like first, and then so you can see we have our X and our O. And now here we notice there's something a bit different from what we're expecting. So according to our grid here, this is rendering from bottom left to the top, but in the way that we are thinking, or rather in the way that this is placed, this is rendering from top to bottom, right? From top left to bottom right. So now we have a bit of conflict in the way we are representing our board and in the way it is being rendered. So now the question is, how can we remedy this, right? So now how we can approach this. So I'm not sure if Arcade has a way of rendering this from top to bottom. Maybe it does, maybe it doesn't, but maybe we can just change this up in our logic such that instead of going from XY all the way up, we can switch it up such that since we're starting from the bottom and going to the top, we can have Y go from now the top to the bottom, right? So Y here, we're still doing range of 3, but now we can do 3 minus Y, right? So that it renders now Y starting from the bottom to the top, right? So that's one way you can do it. We're doing 3, of course, because that's the length of that's the number of grids that we have. So if I run this now, okay, seems like that failed. If I run this again, okay, seems like we have list index out of range. Oh, okay. Since this is starting from 0 all the way to, instead what we'll do is take 2 minus Y, right? And rather than 3 minus Y, since we're starting from 0. So that's a bit of something that we need to debug. And now we can see it renders. Oh, sorry, we also need to change here the text that is rendered to 2 minus Y. And so if I run this now, you can see that now it presents exactly what we have here. So when you have X here and O here, it renders exactly how we need it to render. Now the other thing that you can also look at is the font size that we're rendering, right? So I'll just put font size as a variable here so that we can play it once. I'm seeing it's 18, so maybe I can put something like 50, and then we can see how that looks like. So you'll notice that most of the testing that we are doing here is on using this arcade, right? It's not on the game logic, because we already have the game logic figured out. We just have an issue with how we are rendering it out. Now, another thing that you can do here, you can notice that we are rendering our X at the bottom of our grid, while we can instead render our X at the center of our grid, right? So to do that, so let's imagine there's a smaller grid right inside here, and we need our text to appear within that grid, right? So if we imagine our font size as our grid size, right? So if you imagine our font size as our grid size here, let's say we have another small grid within here where we'll place our text, and let's say it's the size, it's, let's say, 200. Since we have um, our grid as 300, let's make this 200, and let's see how that will look like. First of all, right, this was running, so let me run it again. Right, so you can see now our X and O is a bit bigger, and now it's filling a bit of a space of 200. So if it's filling 200, then so let me just map it out here so that it's a bit easy to see. So if we're using 200 to represent, right? So we have something like 200 here. So if we want it to be at the center, then we need the distance between here to be or rather these spaces to match the deficit that we have. So it's 300 minus 200, which is 100. So we need this to be 50 and this to be 50 so that we are able to fill that space. But since we are looking at, since you're trying to represent this as how, as from this point, which is what we have, this is our X and Y at the moment. So how much further in do we need to go? We need to add 50, right? So here, if I do this logic where we do our X times Y, and then I add 50, and then do the same here for our Y times 300, and then I add 50, then if I run this, then you can see it's a bit more central. Of course, it can be perfect because now we're dealing with X and O's are not rendered within the same space. They have different sizings, so that of course makes the difference. But I think this is workable for now, right? And maybe this 50 we can use it as our as something that we can as a variable. So let's call it font what? Let's call it spacing. Font spacing as 50, so that we can also change it once in a while rather than having to change it all the time. I've also noticed that this is supposed to be square height rather than just 300, so that we're able to change it whenever we need to. And so now in terms of rendering, we are good to go. So we are able to represent our board as is, and we're able to render it as well. So now that we have our board set up, now we need to look at our game logic, which tells us where we need to place everything, right? So I'll just return this to none so that we have our board not being represented. And then now we also have, so this is on draw, and we have on update, right? So you call update on every sprite. So now what we'll also do is when we look at our logic here, we said we'll always start with X because it's a turn-based game, so we need to always start with X. So when we're always starting with X, so we can have our current player represented. Current player is equals to X, right? And then so now that we have our current player, that's where we've started with, and then now we need to know how are we going to select a specific grid, right? So obviously in this case we want to do it with a mouse, right? So when I click on a certain grid, I want X to be drawn there. That means I've selected that specific position. So if I go for this, let's see. So here we have on mouse press, right? On mouse press, we can have our XY, we have the button that was clicked, and we have our key modifiers. I'm not sure what the key modifiers are, but maybe we can take a look at this. Go to the definition. So on mouse press, so I'll just go to this arcade view because now it's inheriting this from the game view. So if I look at this, if I try to find on mouse press, because this is an inherited function, so you can see how it's defined here. It's the arguments. You have x, which is the position of the mouse, y, the position of the y position of the mouse, and then what button is pressed. You can see here we have our examples shown here. We have arcade.mouse button left, arcade.mouse button right, arcade.mouse button middle. I believe we'll be using left, arcade.mouse button left. What else do we have? We have modifiers. I don't think we'll need modifiers because it's basically whether you're using shift or control and such. We won't need that. We only need the X, Y, and the button pressed. So in this case, now we'll be looking at when it comes to this on mouse press, we'll be looking at, we have X and Y pressed. So we need to know if our button is equal to arcade.mouse button left, then that's when we'll need to do our actions. I can remove this pass here. So if our left button is pressed, then the first thing we need to check is where in our grid, we need to know where in our grid this has been pressed, right? So if you're looking at our grid here, let me just run the clean sample that we have, right? So we already have, for example, if you're looking at this bottom half here, we have 0, 0, and we have 300 by 300, right? So at the bottom here, in the way that we are visualizing it in our code, this is 0, 0, and this will be 300 by 300, right? So let's try and map it out right here. So let me choose, let's say, red. So we have our 0, 0 position here, and we have our 300 by 300 position right there. So that will represent our first grid, right? So in that way, what we're going to do is what you're going to do here is we're going to look through for x. So we need for x in a range of 3. I think I'll put this grid as this number 3 as our num grid is equals to 3, so that we use it effectively. So wherever we have here, so for x in range of num grid and for y in range of num grid again, right? So here, in as much as we have this 0, 0, in as much as we have this represented here 0, 0 and 300, 300, we can also map this to now what we already have as x and y, which will be, whoops, just a second there. Looks like I rubbed everything. So if we are mapping this, we have 0, 0, and this will be now 1, 1 in terms of the representation of our grid right here. Right, or rather, let me just use this here. So when we have this board, when we're rendering, we can use 0, 0 and 0, 1 to represent it. Now, of course, we remember also there's that idea where the way we're representing it in code, we are flipping them out, where the 0, 0, 1, 1 is actually the first grid at the top rather than the one at the bottom. So we'll do that flip, of course, but now here we'll just try to represent that in terms of the mouse click. So here, if someone has clicked this position, so I'll just print I'll just print it out. Sorry, so I'm trying to see whether x and y here conform. Actually, I'll need to change this x grid. I'll make this x grid and y grid so that it doesn't conflict with the x and y that has been passed here. So we have our x grid and y grid, and now if I'm looking at x grid, I need to see if x grid is within the range of 0, 0 to 300, 300, right? Which will be this first box right here, right? Let me just use the orange. So that will be this first box right here, right? So that will be 0, 0, 300, 300 when it comes to the pixels, right? So because this, so if I come here, I need to check whether, so what I'll do is I'll check if x grid times now our grid size. So I've used as a grid size. Let me use square spacing. X grid times square spacing, or rather square width. So if x is less than or equal to, sorry, yes, x is less than or equal to x grid times the square width, or rather this is actually supposed to be greater than, so the square width. So in this case, if for example this is if x grid is 0, then that will just mean 0, and then x is less than or equal to this still, right? But now plus our width, which is still square width, right? So basically I'm saying if x is within the range of 0 to, if it's the first case, so we'll have x times square width, that will just be 0, that's for x there, and then x times square width, which will just be 0, plus the square width, which will be, in this case, 300 if you're looking at 0, right? So if it's within that range, and also if it is within the range of our height, right? So we'll have y is greater or equal to x grid times, actually I just remember this for the greater version we'll just use less than. So here we'll do y is greater than y grid times the square height, and then also similarly, and y is less than, right, the, again, y grid times square height plus square height. So I'll just put this in a bracket so that we're able to see it clearly. So what I usually like to do for readability, I like to separate this into, enclose this into brackets so that it makes a bit more sense when you're looking at it. It's just easier to read this way, right? So I enclose that in a bracket and that in a bracket so that we have all our cases visible and seeable, right? So if it is, then we can print. So for this test case, we just print. We'll just print which grid we are at. So we can print x and y, right? Or rather x grid and y grid rather than x and y, right? So if I run this now, so you can see a console here. So if I click here, you can see this is 0, 2, right? So again, 0, 2, since you're starting from the bottom, the height will be inverted in terms of the way we'd like to represent it, right? So that's how we're able to see. So we're able to denote now which grid we are selecting. And then now, in the case where we want to view it the way it's supposed to be, so we can do 2 minus the y grid so that we can actually see the grids the way we are seeing them represented here. So now if I click this, it will be 0, 2, right? So 0, 0 now flips. 0, 0 is now the top here, and then 0, 1, 0, 2, this will be 1, 0, 1, 1, and so on and so forth, right? So if we do it this way, we are able to represent the grid as is. Now, what will happen here is what you're supposed to do is you're supposed to take the current player, right? The current player value, which is x, and place it at this position, x grid and 2 minus y grid. So since we have our self.board here, and then we'll modify the position at x grid and the position as 2 minus y grid, and then this will be equal to self.current player, right? And then what we'll also do after this is we'll need to flip our value so that we can change it up. We need to change our value. If the current player is x, we need to change it to O, right? That's exactly what we had here. Once played, switch the symbol, right? So I'll just create a function within this class still that will handle that. So I'll call it def change player, which will simulate our changing of who is playing, and then of course it will inherit self. So what we'll do, if self.current player is equal to x, then we'll switch to O, and this is supposed to be equals. Then we'll do self.current player is equals to O, right? And then otherwise, if it's not x, then we need to change it back to x, because the only other option is O, right? So that should do it for us. And all we'll do here, once we have completed our mouse press and once our self.board has been changed, then we also need to change the current player here. Self.change player to now what we need to be. So if I run this now, once we click, it should be able to modify. Okay, looks like we have something. List indices must be integers or slices, not tuple. Okay, what does this mean? List indices must be integers or slices, not tuple. Huh, that's very odd. Because you're referring to our board here. And we have our x and our y grid. This should be integers, right? So list indices must be integers or slices, not tuple. We are doing this right? Oh, okay. I've noticed what the issue is. Instead of representing it as, we need to represent it as x in this way with the close the bracket, and then y this way so that you close the square bracket. So if I run this again, now if I try to do this, you can see that once you click, it puts our x. Once I click again, it changes like so, right? So obviously here we have an issue where it does not render it out correctly. We do not have our logic to show whether someone has won or not. However, we're getting there. So once we've changed the player, so now we are able to render correctly, right? So that's the good thing about, so that's the good thing about figuring out how you represent your board. and then also how you'll render it, because now you can see it's rendering accurately as we expect it to do so. Now the next thing we'll do is now put in our game logic, right? So now our game logic is basically checking has this player won, right? So what we can do here, um, um, we can create a function that checks has player won, right? And we'll use self. So here, basically what we'll do is we'll now traverse. So like we said here, we need to check all these 8 possibilities. The 8 possibilities that are there for this. So if you're in there last time, what he said is our 8 possibilities are, we have this, this, and this. We have three vertical, we have 3 horizontal, and we have 2 diagonal, right? So those are our 8 options. So we need to be able to check that, right? So I've just noticed that we had a third rule here. Once a position is filled, you cannot fill it again, which I would like to check. So you can notice here that if I click here, X, and then I click again, it will change, right? So this is not supposed to happen. So how can we prevent that? We can do that by checking as well if this position is filled before we even fill it, right? So if this, right? So since we're using none whenever it's not filled, then if we do this, then it will pass. So we can just do if not for this case, so that we are able to do our render, right? If not, self the board, then we can modify. So if I now press the same place again, you can see that nothing changes. It does not change the player, and then it change, right? So now it works the way it's supposed to work, right? Great. Now so the other function that we've done here is has player won. So obviously we need to check if the player has won before we change the player. So we can just call self.hasPlayer1 right here. And the beauty of having this in a class is we don't need to keep passing who the current player is, since it's already enclosed within the class, right? So here, now how do we traverse through and check whether this person has won? So there's the easy way, which is the horizontal way. So if I just highlight this in red here, so the horizontal are very easy to check. We just check whether these values within here are the same, right? Or equal the current player. So what you can do, of course, we need to do our loop. So for x in a range of forgotten what we called this, num grid, right? And then for y in range of num grid, again, what you're going to do is so now let me just put pass. So if you want to check for the values in within the horizontal, then for horizontal, then what we'll do is we need to see whether these match. So what we'll do is, as we're looping through this y, so we can put horizontal match here is equals to false, right? And then for y in range, So we can now check if the horizontal match is coming through, right? So how do you do that? We can check. So how do we check the horizontal match? We can check now if the value at x and y, right? The value at our board x and then board y is equal to our current player, then our values are matching, right? So we can put our horizontal match as true, right? And then if it's not, then you can put our horizontal match as false, right? So now the other thing is once we find that our horizontal match is false, then we don't need to check again on that horizontal plane. So if we find the horizontal match is false, then we need to break so that we don't need to check again, right? So now we break at that point. So that what that will do is it will prevent us from having this situation where we come here, for example, we find that x is true, right? And then we come here, we find that x is false, right? So at this point, we don't need to check again whether this is x because you already know that the match is false. So that's basically how that comes about. So that's why we need to do our break here, right? Now the next thing we need to check is our vertical match, right? So the vertical match is specifically for a specific height, right? So now the vertical match will basically be checking majorly on the x-axis. So vertical match, we begin it as false. So now how can we represent this vertical match, right? So if you try and look at the logic here, we can see that we have we'll have to get let's say for x equals 0, we'll or rather for y equals 0 here, we'll need to check x at 0, x at 1, and x at 2, right? So that means we need to flip it out. So in this case, we had x being our first loop and y being our second loop. So in this case, we need to flip it out such that y is our first loop and x is our internal loop. So I'll just create another one here so that we can separate them. So I'll just comment here as well, check for horizontal match. And then here we can also check for vertical match, right? So for our vertical match, we'll start with for y in range of num grid. Then for x in range of num grid. So vertical match, of course, will be within here, so that we're looking at each case by each case, and then our check will not be any different from as it was before. We'll if it is matching across the board, then that is okay. If it is not, then false, and we break, right? So in this case, so now let's test out these cases, right? So if we'll just print out if vertical match, we'll print vertical match. If horizontal match, we'll print horizontal match. And then if, okay, we do not have a diagonal match yet. So no worries about that. So we'll just check these first conditions. We'll just test out whether our logic makes sense before we look at the diagonal match. So it's usually best to test out each case on its own. So or luckily for us, we've already put setup such that it can evaluate every time. So I'll just make it like so, and then here. Okay, looks like nothing is being printed. Interesting. So nothing is being printed, which means there's something not going right. So what are we doing wrong here? We have self that has player 1. So if we print checking if player 1 here, right? So every time it's checking if player 1. So we're not clearly our vertical check is not working. Let's try the horizontal check and see if it's working correctly. Interesting. So it looks like we are missing out on something, right? So because you're looking if self.y equals so something is not adding up. So maybe I can print, I'll just try with testing the horizontal match first. So we can just print horizontal true, and I'll indicate x and y as well, so that we see how that goes. So we have horizontal true on 0, 0. In this case, it should be horizontal true on 0, 1. Okay. So horizontal true on 0, 0 and 1, 0. Then last is horizontal true on 2, 0. Okay, so the three are coming out correctly. So first of all, what I'm noticing is 1. We are getting the x's, for the x's we're getting correctly. So for the first case we're getting correctly, and the reason I've just noticed that the reason that we are not getting our exact match is because once we evaluate this, we're still going to evaluate the rest, and we're still going to set this to false, which means if we get horizontal match is true here, then we need to break so that we don't need to evaluate, because it's going to look at the first position, and then since it's already true, we don't need to check again, right? And I think I'll implement this for vertical as well, because it's still a prize. Vertical match, then break as well, right? So now let's see how this works out. So we have so definitely we have an issue when we're dealing with something different. So horizontal true, working out correctly. So now yes, there we go, we have our vertical match. Nice. So another problem we have here is, right, wait a second, this is saying vertical match. Did I print? That is odd. This is supposed to be horizontal match and not vertical match. Oh, what am I getting wrong here? They actually flip these out? Okay, so x and y. Okay. Yes, that does make sense. That does make sense why it's vertical match. That is true. Because here, if you're looking at x and y, so our x will be these. So if we're looking at y changing, no, that doesn't make sense. Horizontal match is true. So now our code is working, but not the way I'm expecting it to work. If you have done programming for a while, then sometimes this happens, right? So this is giving me vertical match, which is not exactly what I'm expecting it to print. I'm expecting it to print horizontal match, right? So now if I look at this, x is the one that is changing. So you have 0, 1, and 2. So if x is the one that is changing, you have x at 0. Wow, it does not make any sense to me. Okay. Anyway, let me just test my version of vertical and see how that looks like. Whether that is working correctly. Checking player 1. So horizontal match is true now. Well, it's supposed to be vertical, and then that also works. So okay, so our code works. It's just our naming that is not accurate, right? This should be working the way I'm expecting it, right? So x is changing and then y is remaining the same. This should be vertical match. Wow, it's crazy. Anyway, I won't dwell too much on it. At least for now, we know it will tell me if we've won. It's just that maybe I'll think about that later. It's gonna tear up in my mind a bit. So let's look at the diagonal match. So the diagonal match. So for the diagonal match, we just need to check whether this, and this come together. So the good thing about this 3 is when you're looking at this, when going across, we have this would be 0, 0. If you're looking at the indexes, this would be 1, 1, and this would be 2, 2. So that means we have the 3 matching, right? So that's one way that we can look at it. We have the 3 matching, so that's one way that we can look at that diagonal. So what I'm going to do here is I'm going to create a diagonal match here, which is equals to false, of course. Now, what I'm going to do is I'm going to be checking if we have a diagonal match, right? So now, whenever we find that self.board at xy is the same, so we're also going to be evaluating if x is equals to y, then we can say diagonal match is equals to true, right? So in this case, I'm not separating it out, it's just within the same. Of course, you can separate, but I just prefer to do it this way. Diagonal match is true. And then again, if x is equals to y, then diagonal match is false, right? So if horizontal match, then break. That is okay. Now, for the diagonal match, this poses a bit of a problem. So maybe I will separate this because I'm noticing this might be a bit tricky. So for x in, I'll just copy what you have here actually. just copy this down here. Right. So this time I'm checking for diagonal match. I wouldn't need this horizontal match. So so if x equals y, actually no, I'll just do if this is the same, then if since we're checking on diagonal match, I'll just make sure I change this, and then I'll make sure that we always have this condition that if x is equals to y, then we need to modify our values, right? If x is equals to y, then diagonal match is true. Now this is for whenever we are going across, right? So if x is equals to y, diagonal match is true, and then we can break, right? So why is that? We only need to check for the situation where x is equals to y, right? So which means actually I'm actually going a long way with this. So rather than doing that, you can just do point, and for point in this, since we are still looking at the ones that match, we can just reduce this to if self at point is equals to self the current player, then diagonal match is true, right? So else diagonal match is false, and we can break from that point, right? So anytime we get it's false, we need to break, right? So check for diagonal match. So this is basically left to right. So what about right to left, right? So when you're looking at right to left, then what changes is our direction, right? So you have x changing up. So if you're looking at left to right here, here in this direction, then we'll be looking at 0 2, then we look at 1 1, and then we look at 0 0. So if we are to represent this, if we look in reference to 0 0 1 1 and 2 2, the only difference is the y is beginning from 2 going down to 0, right? So if you're looking at this here, we can use the same logic here, except for y starting from 2 going all the way down to 0. So this should also give us our result the way we need it. And then also if you have evaluated diagonal match here and it's already true, then we don't need to check any other condition. In fact, if we have a horizontal match, we do not need to check anything else. So if not horizontal match, then do the rest. All right. Same for here. If not vertical match, then you can do this. So basically, if we've not found that whatever we're evaluating is correct, then we only need to, or rather, when we've already found our answer, then we don't need to check again. So that's how we can put that out there. If not vertical match, and then if not diagonal match, then continue checking. And then here, if diagonal match, then print. So actually, I'll just change this to main logic. If vertical match or horizontal match or diagonal match, Then we'll say we'll just print this out, self.current player. Let me say has one, right? Then we run this. So now we have x and O, x and O, and then x. So x has one because of the diagonal, right? So you can also test the other diagonal. So x, O, x, O, x. So x has one. And then if you're also evaluating, you can also evaluate the horizontal and the vertical. Oops. Seems like I made it a bit hard for myself. Like so. Okay. Vertical match. Okay. So now we dive into an error here. So it says if vertical match. So vertical match is cannot access local variable, but it is not associated with a value, right? So that means we need to declare this because these are declared within if statements. The vertical match is within an if statement. That means it is not accessible at this point. So what we can do here is simply declare all of these variables at the top. Horizontal match, vertical match here equals false, and diagonal match equals false. That way, these variables are accessible within the entire function, and while we're in these if statements, then we are only modifying the values. The scope of the values is the whole function and not just within the if statement. So that's on variable scope. You can check it out. You can check out the video I made on that up there. So if I run this here now, so what we did last time was I think vertical, so you can just do vertical. So now x is 1. If I do horizontal, x, O, x, O, x. So you can see x has 1, right? So now our game logic is working out, right? So now that we have that simplified, our game logic is working out. All we need is now to have a way of showing that the player has won. So maybe I don't know how we can do that. We can maybe have a pop-up. Let me see how we can do that, because what we really need, or rather we can change the window to a new one. Let's see what Arcade can offer us. So maybe let's see, shooting with sprites, sound effects, music, sizable backgrounds, cameras. Okay, we have view management. Okay, let's see. Okay, so you can see here there's using views for a pause screen. So maybe we can use views so that we're able to change things up. So you can see here we have a menu view, we have a window.show view menu, then we have arcade.run. Okay, so where is this person using this menu? Let me see. So here we also have this person is also doing so you have a pause view on key press, and then we can say self.window.show view pause. Okay, nice. So if I copy this, our menu view, I guess, or our pause view, I think I'll just copy the menu view so that we use that. Then we modify it however we need. So I'll just create that menu view right here. Right. We have our width, our height. I think I'll just take window width here and window height here. Right. So we just I'll just try and test this out. And then here we can create menu, or rather I'll actually change this name so that it suits us. So I just rename that symbol to win view, like so. And then once we have our win view, what we can do is create this win view here. So for the sake of testing, I'll just show the win view. And then I'll run. Aha. Nice. Interesting. Okay. So that's how that works. It seems it's already rigged to disappear. Let me see. So they're doing on mouse press, it shows the game view window. Okay. If this is the case, then I think I'll just return this to our menu view since it works perfectly for us. And then I'll say, so instead of having our game view here, we can start with our menu view. So I'll just change this to menu. So if I run this, you can see menu screen, click to advance, right? So what I'll do is I'll change this to Tic Tac Toe, and then I'll say click to play, right? So this is the beauty of having code written for you. So Tic Tac Toe, click to play, and once you click, you have your screen there, and then now you can play, right? So now our concern was about having our when someone has won, how do we display that? So we need another view. I think I'll copy this pause view that we have here and see what we can do with that. We can modify it later on. So I'll just make sure that our width here is window width, and our height here is window height, right? So this is the beauty of getting code online. I usually advise that it's best that you only do this, you only copy code whenever you understand the code, right? So in this case, we already know what a view is because that's what we've been working on our game view. We already know what on draw is. We have on show view, we have this color changing. So I believe on show view is simply when the view when we've changed to this view. Then next we have draw LRBT rectangle. Draw a rectangle by specifying left, right, bottom, and top edges. Oh, this will have been convenient if we knew it earlier. Then we have our draw text. Okay, so let me see. So the implementation to add this view, I just want to see where the pause was set up. So you can see here on key press escape. We'll actually copy that. So on our game view, here, where is our game view? So on our game view, we have on key press, so we can add this. So obviously you can see here we go if the escape key is pressed, then it comes to the pause view, and it create the pause view, and then we share now the window. So if I run this now, when I click to play, if I click escape, okay, so we have an issue. Object has no attribute player sprite. Right. So I believe that's what it's saying on line 55. So if I just go here, player sprite, right? I think I'll exclude this for since you're not really using this. I'll just exclude it. Same for this. So you just have our pause menu, which is just screen text. So if I run this now, whenever we press escape, we have paused, and then escape to return or enter to reset. Right. So it just clears up again, right? So you can see the logic. So escape to return, enter to reset. I just need to see how on key press. So on key press here, when escape, we show the view of the game view. We return the game view that we already had, and then so that means, right, so whenever we're hitting our pause view, we also return the game view, right? We pass the game view so that we keep that instance showing, right? And then at the end of it now, we can be able to return once someone presses escape. So that returns us to an instance. And the other thing here is if you press enter, it creates a new game view and then shows that game, right? So that works for us as well. It allows us to have that example showing on. So now, if we need our you've won view, right? So I've copied this, and then I'll call it our game overview. Game overview, right? And so our game overview, I think I'll keep this logic where if you press enter, it will reset the game, which means here our text here, I will just say this person has won. So I think I'll also pass the winning player here. Or actually, no, since we're passing the game view, then we can be able to access the current player. So we'll just have here. So I'll make this into a formatted text so that I can say game view, self.game view, which is what we've passed, dot current player has won, like so, right? So that's what we need to display. I'll just do a sample of the game overview so that I can see. Right, so once you've set that up, the game overview, here I can also, let's see, sub the current player. So once the player has won, then we can instead create now our game view, right? Sorry, game overview, which takes in that, and then now we see, just like we had it before here, where we set the self.window to show another view. So we come here as well, self.window.show view to the game overview, right? And so if I run this, now you'll have Tic Tac Toe, click to play, and then once you click, so you'll just make X win here, right? So now we have an error in it, missing required positional argument game view. Of course, forgot we're supposed to pass. So here, whenever we create our game overview, we also need to pass this current view. So I'll just pass self. So self is the current view, which is the current game view that we have. So now if I run this and we attempt this, right, there we go. So now we have an issue where it says O has won instead of saying X has won, right? So why is that? That would be the question. So the issue is here, in as much as we are opening the game view, once this exits, right, we have our show view, but remember we are exiting this has player 1 function. So if you look at where we've implemented this, once we run this has player 1, we also change the player, right? So now that means we only need to change the player if no player has won. So what we'll do here in our has player 1 function, we'll return true if the player has won. Otherwise, the default case will be return false. Then what we can do now in our evaluation here, we'll do if not self player has won, right, which will return false if the player has not won. Then we'll change player so that you can show the correct person. So if we run this now, we'll have Tic Tac Toe showing, and then when you click x0 x0 x, and now it shows X as 1. Of course, here we have this posed value. I think I'll just swap these two values here. So on our game overview, I'll just translate this text here. Instead of showing posed, it will show this person as 1, and then I'll remove this. Right? So also, as I'm looking at this, I'm also noticing there's this anchor X center. So I'm not sure what that means. So now I'll just ignore that for now. Our game is working. I don't need to add any more checks. But now we have that X is 1, press enter to reset. So when you press enter, you start again. X is 1. Let's make the O win this time, right? O has won, right? So now our game works, and that is how you do your game, right? So that's how you create Tic Tac Toe. Right, I'm sure this has been a bit of a long video, but I just wanted to show you how you can do it, or how it is in the background. How as a developer you're really looking into how you're going to implement things. You need to keep doing the research. You need to keep looking at the documentation. It's something that needs to keep happening as you're doing your development. It's not clear cut that you already know everything that you need to do. And also, you've also seen how we look at bugs, the way we use our print statement to look at what's happening in our code, so that we can debug it and then make changes in our code, right? So that's simply how you would do your Tic Tac Toe. And I really hope you've enjoyed. I hope you've learned. I hope this long type of raw video works for you. You can maybe share what you guys think about it. It's a bit unfiltered, showing everything that is happening. So maybe you guys can share reviews on that as well. So I hope to see you next time. Cheers. So one more thing that I forgot, I'll also have this game as is on itch.io. I'll share the link in the description below so that you can also check it out and get to play. I'll also put a link on the GitHub repository so that you can also clone it and look at the code yourself. Maybe you'd want to just keep it and modify for yourself. You're very welcome to do so. I hope it helps you. Yeah.